of an object or a system that conveys precise and detailed information to aid in its design, manufacture, and assembly. It's a universal language that's used by engineers, designers, and technicians to communicate technical information effectively. The purpose of engineering drawing is to provide a clear and unambiguous representation of an object's shape, size, dimensions, materials, tolerances, and any other relevant information that's necessary. It also serves as a blueprint that guides the production and assembly processes, ensuring consistency and accuracy in the final product. Let's talk about the key aspects of engineering drawing. The very first key aspect of engineering drawing is visualization. Engineering drawings allow the visualization of a complex object or systems in a two-dimensional format. They provide a realistic and scaled-down representation of the object's physical characteristics, including its shapes, features, and proportions. Standards and conventions. In engineering drawing, there are a specific set of standards and conventions that we need to follow to ensure consistency and understandability across industries and countries. These standards govern the use of symbols, line types, dimensions, notations, and any other element of the drawing. The third is a geometric representation. In engineering drawing, we use various geometric representations like lines, arcs, circles, polygons to represent different features of the object. Lines of different types, for example solid, dashed, or dot, are used to denote different types of edges or surfaces. Then comes dimensions and tolerances. We also provide precise measurements and dimensions of the object features, including length, width, height, angles, and curves. Tolerances define the acceptable range of variations for these dimensions, ensuring proper fit and functionality. Annotations and symbols. Drawings can contain annotations and symbols to convey additional information that cannot be easily represented geometrically. These may include notes, labels, material specifications, surface finish requirements, assembly instructions, and any other relevant details. Views and projections. Another important key aspect of engineering drawing, which includes multiple views of the object from different angles to provide a more comprehensive understanding of its three-dimensional shape. Common views include the front view, top view, side view, and the isometric projections, which we shall see later on. Then comes assemblies and exploded view. For a more complex system or assemblies, engineering drawings may include the exploded view of an object, where individual components are separated to show their relationship and the assembly sequence. This further aids in understanding how the total part fits together. And lastly, the most important key aspect of engineering drawing, which is computer-aided design. With the advent of computer-aided design softwares, engineering drawings are now predominantly created and stored electronically. CAD tools provide precise drafting capabilities, easy editing, and the ability to generate 3D models and simulations directly from the designs. Engineering drawings are vital in various engineering disciplines, including the mechanical discipline, civil, electrical, and even the architectural field. They serve as a critical communication tool between designers, engineers, manufacturers, and suppliers, ensuring accurate and efficient realization of designs into physical objects or systems. With that, we now move into understanding what is the angle of projection. The term angle of projection refers to the orientation or the position from which an object is viewed or projected into a two-dimensional surface, such as a drawing or a screen. It's an essential concept in drawing and engineering, particularly in the field of orthographic projection. In engineering drawing, objects are typically represented using orthographic projections, which involve projecting the object into multiple 2D views, which could be front view, top view, or side view, to provide a more comprehensive understanding of its shape and dimensions. The angles from which these views are projected are known as the angles of projection. There are two primary angles of projection in engineering drawing, which is the first angle projection and the third angle projection. Before we talk about the first and third angle projection, let's talk about quadrants. We know that we have 4 different quadrants, which are given by the first, second, and the third and the fourth quadrant. When viewing an object from the first quadrant, that is a first angle projection. If the object is being viewed from the third quadrant, that means the object is placed in the third quadrant and then the views are being drawn. That's a third angle projection. So in summary, when we talk about the first angle and the third angle projection, in the first angle projection, the object is placed in the first quadrant relative to the projection planes. The object is imagined to be enclosed within a transparent box with the views projected onto the walls of the box. So the observer is positioned outside the box looking towards the object. So in the first angle projection, you have the front view. The top view is then placed underneath the front view and the right side view is placed to the left side. Then comes the third angle projection. In the third angle projection, it's just the opposite of the first angle projection. The object is placed in the third quadrant and once again, it's understood that a viewer is looking at the object from the side. In the third angle projection, the front view is placed in general, top view is placed above the front view, and the side view or the right side view is placed to the right side of the object itself or to the right side of the front view. The choice between first angle and third angle projections depend on the region and the industry standards. Different countries and organizations have their own preferred conventions. So the angle of projection plays a very important role in engineering drawing as they basically determine the relationship and alignment between different views of an object. By projecting the object from different angles, orthographic projections provide a comprehensive representation of its shape, size, and features, thus allowing engineers, designers, and manufacturers to visualize and understand the object accurately. Since we talked about views in these angles of projections, it's finally time for us to talk about drawing views. What are drawing views? Drawing views refer to the specific representation of an object or a system in engineering drawing. They are basically 2D projections of the object from different angles or orientations, thus providing a more comprehensive understanding of an object's shape, size, and features. Drawing tools are essential as they communicate design intent, they facilitate manufacturing processes, and they ensure accurate assembly. So in engineering drawing, there are several standard views which are commonly used to represent an object. The first one is a front view. The front view is the primary view and typically shows the most essential feature of the object. It represents the object as seen when you look at it directly at its front face. The front view is often used as a reference point for positioning the other views. Then comes the top view. Another view which is seen from the top or from above, looking down on the top face of the object. It provides information about the object's width, length, and helps us understand its overall shape and symmetries. Then comes the side views. In the side view, the object may be seen from the left or from the right, depending on which side the designer tries to choose. These views provide information about the object's height and depth and help us understand its cross-sectional features and profiles. Then comes the bottom view. The bottom view represents the object as seen from below, looking up at its bottom face. It's useful for understanding the object's base or the underside features of an object. Then comes the rear view of an object. The rear view is the object as seen from behind, which is opposite to the front view. It provides information about the object's features and helps us understand its shape and any rear-facing component, if any. Then comes the isometric view. In the isometric view, we represent the object in a 3D-like format, where all three axes, which is the length, width, and height, are shown equally. Isometric views are useful when you're visualizing the object's overall shape and proportion. Then we move on to sectional views. In sectional view, we basically represent a slice or cut through of the object, which reveals the internal features or cross-sectional details of the object. It helps us visualize hidden or obscure components that are not visible in a regular view. At the same time, we also have an important view known as the exploded view. An exploded view shows the components of an assembly separated or exploded from their normal positions, often when connecting with lines or arrows that indicate their relationships and assembly sequence. This view helps us in understanding how the parts fit together and how they interact. These drawing views collectively provide a comprehensive representation of the object's shape, dimensions, features, and relationships, thus ensuring clear communication between designers, engineers, and manufacturers. By using different views, engineering drawings enable precise visualization, accurate interpretation, and efficient production of the desired object or system. Thank you. Welcome to an introduction to AutoCAD. AutoCAD, which stands for Computer Aided Design, is a software application used for creating 2D and 3D designs, drafting, and modeling. It has been a leading tool in the field of computer aided design and has revolutionized the way architectural, engineering, and construction professionals work. Let's first talk about the history of AutoCAD. AutoCAD was developed by Autodesk, a company founded in 1982. The initial development of AutoCAD, however, can be traced back to the early 1970s when Autodesk's co-founder, John Walker, started working on creating a computer program for creating technical drawings. The release of AutoCAD version 1 happened in 1982, which was done in December, marking the official launch of the software. It was initially available for the Apple Macintosh platform and later for the IBM PC platform. AutoCAD 1.0 introduced features like entity snapping, layers, and the ability to save and load drawing. AutoCAD gained popularity rapidly in the 1980s and 1990s due to its user-friendly interface, a powerful functionality, and compatibility with various hardware platforms. It became the industrial standard for computer-aided design and was widely adopted in architectural, engineering, and manufacturing industries. The introduction of 3D functionality in 1988 gave modeling capability that allowed users to create and visualize 3D objects and design. The 3D functionality further expanded in subsequent versions, providing more advanced modeling tools and rendering capabilities. In the early 1990s, AutoCAD transitioned from the DOS-based system to the Microsoft Windows operating system. This transition brought about improved graphics, enhanced user interface, and better integration with other Windows applications, making AutoCAD more accessible and even more user-friendly. In 1993, Autodesk introduced AutoCAD LT, a lighter and more affordable version of AutoCAD that focused primarily on 2D drafting functionalities. AutoCAD LT became popular amongst small businesses and individuals who did not require the full 3D modeling capabilities of the standard AutoCAD. Autodesk has continued to release new versions of AutoCAD regularly, introducing innovative features and enhancements. These include improved 3D modeling tools, advanced rendering capabilities, integration with other Autodesk software applications, support for cloud-based collaborations, and mobile applications for accessing and editing AutoCAD files on the go. Today, AutoCAD remains one of the most widely used CAD softwares worldwide, offering a comprehensive set of tools for creating precise 2D and 3D design. It has greatly influenced the field of computer-aided design and has become an essential tool for professionals in architecture, engineering, construction, manufacturing, and other related industries. With this, we now move on to just having a tiny discussion about the AutoCAD user interface. The AutoCAD user interface looks kind of like this when you open a new file. We'll see how to open a new file in the upcoming sessions, but when you do, this is what you'll be seeing. In here, on the top left corner, this is the quick panel. which is a dockable panel in AutoCAD that provides quick access to various tools and commands. It's customizable, allowing you to add or remove tools based on your preferences. You can dock the quick panel to the left or the right side of the AutoCAD window as well for easy access to frequently used commands. This is the Ribbon tab, which is a section within the ribbon interface of AutoCAD that organizes related commands and tools. Each tab represents a specific category or task such as home, insert, annotate, modify, and so on. By clicking on either of these tabs, you can access a collection of tools and options relevant to that category. Then we have the Drawing Switcher panel, which is a part of the ribbon interface once again. It displays a list of open drawings, allowing you to quickly switch between different drawings without navigating through menus or closing and opening files again and again. This panel enhances productivity by providing easy access to multiple drawings simultaneously. We then have the ribbon. The ribbon is a key component of the AutoCAD user interface. It's this horizontal strip that's located below the menu bar and contains multiple tabs, panels, and galleries. The ribbon organizes a wide range of tools, commands, and options into local categories, making them easily accessible and reducing the need for extensive menu navigation. On the right, we have the View Cube, which is a navigational tool that helps control the orientation of the drawing. It's a visual representation of a cube displayed at the top right corner of the drawing area. By clicking and dragging on the View Cube, you can actually rotate the view to different angles. The default angle is set at top, but if you wish, you may switch to the bottom view, front view, back, left, right, or even restore to an isometric view. Then, at the bottom left corner, we have the UCS. The UCS, or the User Coordinate System, in AutoCAD is a coordinate system that defines the orientation and the position of objects within a drawing. It provides a reference framework for creating and manipulating geometry. By default, the UCS aligns with the drawing's X, Y, and Z axis, but you can modify it to suit specific requirements, such as working in a different plane or aligning it with a specific object. Underneath it, you have the Model and Layers switcher, which allows you to work with multiple views of your drawing using models and layout tabs. The Model tab represents the 3D model space where you create and modify the actual design. The Layouts tab, on the other hand, represents a 2D paper space for plotting and printing purposes. The Model and Layout switcher provides a quick way to switch between these different working spaces. To the right, you then have the Command panel. The Command panel, also known as the Command line, is located at the bottom of the AutoCAD window, which serves as an interactive text-based interface where you can enter commands and options to execute a specific action. It displays prompts, messages, and dynamic inputs, allowing you to interact with AutoCAD by typing commands or selecting options from the provided choices. On the right of the Command panel, you then have Tool Status Bar. The Tool Status Bar is a section located at the right bottom of AutoCAD window, which is just under the Command panel. It displays various options and settings related to the active tools or commands. The Tool Status Bar provides quick access to modify the behavior or properties of the selected tool, enhancing efficiency and productivity during the design process. These tools and features in AutoCAD contribute to a comprehensive and efficient user interface, thus empowering you and me, the users, to navigate, create, and manipulate drawings effectively. Now, we move on to talking about the coordinate systems in AutoCAD. Coordinate systems are fundamental to representing and manipulating positions and orientations in a geometric space. In the context of computer graphics and CAD software like AutoCAD, there are two commonly used coordinate systems: the Cartesian coordinate system and the polar coordinate system. The Cartesian coordinate system is based on a grid of perpendicular lines that form three axes: X, Y, and Z. It represents positions in 3D space using numerical values of X, Y, and Z, whereas the intersection of these three axes is known as the origin, given by 0, 0, 0. The x-axis extends horizontally, the y-axis extends vertically, and the z-axis extends perpendicular to the x and y-axis, or the xy plane. Each point in this system is defined by its distance along each axis from the origin. Then we have the polar coordinate system. The polar coordinate system represents positions using two values: the distance from the origin given by r and the angle theta. Instead of using perpendicular axis like the Cartesian system, the polar system uses a single axis that originates from the origin, called as the radial axis. The distance from the origin is measured along the radial axis, while the angle is measured in a counterclockwise direction from the reference direction. Polar coordinate systems are usually used to represent circular or radial patterns. Apart from these two, we also have something known as a spherical coordinate system, which uses three values like radial distance, polar angle, and azimuthal angle. We will not be talking about the spherical coordinate system in this scope, but that is also another system that is available. In AutoCAD, the user can choose a specific coordinate system to work with based on their requirements. The default coordinate system is the Cartesian system, but a user can switch to other systems such as polar or spherical as needed. Additionally, AutoCAD also allows for manipulation and transformation of the coordinate system through the UCS, enabling users to work in different planes or align with specific objects in their design. So in the next session, we'll actually get into AutoCAD and have a look at all these different tools and explore the user interface and also get started with AutoCAD. So I'll see you in the next session. Until then, stay safe, take care, bye-bye. So in this session, we get a hands-on experience of how we can actually work with AutoCAD. But before we actually dive into the working of AutoCAD, let's first have a short description about file management. We want to understand how organizing and managing files in AutoCAD is crucial. So we talk about the importance of file management in AutoCAD. The first thing is accessibility and efficiency. Proper file organization ensures easy and quick access to the files. When the files are arranged systematically, it becomes effortless to locate and retrieve specific drawings or data. This saves time and prevents frustration later on, which can happen by searching through cluttered folders or misplaced files. Then, collaboration and teamwork. In any collaborative environment where multiple teams works on the same project, organizing files becomes even more crucial. Proper file management enables smooth collaboration by allowing the team members to find the latest versions of drawings, references files, or even design specifications, thus promoting further teamwork and reduces the chance of errors or confusions. AutoCAD projects often go through multiple iterations and revisions. By organizing files, you can maintain a clear record of different versions and iterations of a drawing. This helps you track your progress of the project, revert to the previous versions if needed, and maintain a history of design changes. Project continuity and archiving. Organized file management ensures project continuity. If someone new joins the project or if you need to revisit an old project, having a well-structured file makes it easier to understand the project's context, locate a specific drawing, and even pick up where you left off. Additionally, proper file management facilitates archiving and long-term storage of projects, ensuring that important files are preserved for future references or any legal requirements. Lastly, a well-organized file structure makes it easy to implement backup strategies and safeguard your data. By categorizing and storing files in logical folders, you can effectively back up important project files, reducing the risk of data loss, which can occur due to hardware failures, software issues, or any unforeseen circumstances. So, let's dive into AutoCAD and have a look at how we can manage our files as well. So now we're here in AutoCAD and it's finally time for us to actually discuss how we can actually create, open, save and close drawings, which is an important part when you are trying to manage your files. In order to create a new file, when you actually open AutoCAD, this is what your screen is going to look like. Over here, you can just click on New and a new drawing we'll get started. All right, I'm just going to create a bunch of rectangles here just for the sake of a sort of drawing. Doesn't matter how I'm doing it, we'll discuss that later on. But I've just created some drawings over here. Once you're done making all your drawings, if you want to save the file, you can very simply use the shortcut Ctrl+S, or you can click on the A logo at the top left corner, and there you can click on Save or Save As. When you click on Save or Save As, it'll give you the choice to choose a location where you would like to save your file. In my case, I'm going to choose my desktop, and in my desktop, I would like to save my drawing. When you do give the name for your file, don't leave the name as drawing2, as that would not be a good practice. When giving a file name, give a name that has meaning or purpose. Basically, give the purpose of the sheet as your file name. That way, it'll add more clarity when you are searching for this particular file. Now, since I've made a bunch of rectangles, I'm going to call it rectangles.dwg. Now, .dwg is the basic extension for an AutoCAD drawing file. You can actually choose another version if you wish to give your drawing file in another version of AutoCAD. Sometimes there might be some people who might have a lower version of AutoCAD. So if you need to give them a drawing file in that format, you can choose that version as well. I'm going to leave it at 2018 itself and hit save. And that's it. Once you're done, in order to close your drawings, you can either click on this and close the drawing tab, or you can just shut your entire software. That's completely up to you. But how do you open an already existing drawing? If you have a drawing saved somewhere and you wish to open it, you can either click on this open option over here, which will automatically open this box where you can choose your files from. And the same option is also available at the top left corner. In the top left corner, you can click on the A logo, which is the AutoCAD logo, and then click on open, or you can click on this icon over here, which is the same thing. It is also used to open a drawing sheet. So either of the three options can be used. So let's click on that and choose our drawing sheet and click open. And that's it. Our drawings have been loaded. So this is how you basically create, open, save, and close drawings in AutoCAD. Talking about how you can modify a few things in AutoCAD in the quick access toolbar. This is the toolbar which basically holds all your quick commands. And in this toolbar, if you kind of right click, you'll see quite a few different options here. So the ones that we would like to concern ourselves with would be one, which is customize access toolbar. So when you click on customize access toolbar, you kind of get this. In this, you get all the different options that are present in AutoCAD. And if you want any option to be available, you can actually just search for them. Or if, let's say, you know that one of these options are here, like for example, the arc, what you got to do is just pick, drag and drop. That's it. And that option will now be available in the quick access toolbar. If you want to remove that, and yes, absolutely, do make sure you save the changes by clicking on apply and then clicking OK. But once that is there, if you want to get rid of it or something, then you can very simply just right click on it and click on remove from quick access toolbar, and that icon will disappear. If you wish to separate these icons by putting some kind of separator between them, you just kind of right click and click add separator, which will add this kind of line that separates all the tools, that lets you visually understand the difference between them. And if you want to remove the separator, once again, just right click and remove from quick access toolbar. This is basically your ribbons tab, and under each of these tabs you have different category of options that will be presented in this ribbon. The ribbon is basically all of these options that you're seeing over here. So this is the home ribbon, this is the insert ribbon, this is the annotations ribbon, parametric, view, manage, output, collaborate and express tools. Here too you can just right click and click on show tabs, and then you can choose which tab you don't want. Like for example, if I don't want this express tools, I can just click on it and then express tools will be gone. Again, right click, show tabs, and let's say you don't want collaborate. Click on that and collaborate will be gone. If you want those options back again, just show tabs and select those options once again. Same as usual. Right click, show tabs and express tools, and that's there once again. Inside the ribbon tab, this entire thing is your ribbon. Inside this ribbon, each of these are panels. So this is the draw panel, the modify panel, the annotations, layers, block, properties, groups, utilities, clipboard, and the view panel. So if you right click anywhere, you get this option of show panels. If you don't want any of these panels, you can just right click on there, and whichever panel you would want to hide, you can just click on that. Like for example, let's say I don't want this properties panel. Click on that, the properties panel will be hidden. Right click over there once again and show panels. Click on properties once again, and that's present again over there. And yes, another thing you can do with the quick access toolbar that I forgot to mention is if you right click on it and click show quick access toolbar below the ribbon, then this access toolbar will be present over here so that you can kind of quickly just navigate through all the options that you need. All right. So once again, right click on it and then show quick access toolbar above the ribbon. Right. And that's basically how you'll work with the GUI of AutoCAD. Moving on, we now have a discussion about workspaces in AutoCAD, which basically refer to a predefined set of tools, menus, and interfaces configurations that are tailored to specific tasks or workflows. They allow a user to switch between different working environments based on requirements. So if you ever want to switch between the workspace that's present in AutoCAD, where you can actually switch between like the drafting and annotation view, which is basically this workspace that you are given with, you can actually just go down over here and you'll see this little settings icon. You can just kind of hover over it and you can see it says workspace switching. Click on that and then you can switch between workspaces. So if I click on 3D Basics, I'll now be taken to the 3D Basics workspace, which lets me operate with the 3D tools and so on. Similarly, I click over there and I can switch back to drawing and annotations and come back to actually making 2D drawings and so on. So basically, the usage of workspaces depends on what kind of outcome we're looking for. They provide a more streamlined and context-specific interface, which displays all the relevant tools and commands while hiding all the unnecessary ones. Like when you are concerned with 3D basics, a 3D modeling workspace will prioritize all the tools related to the 3D modeling requirements. Whereas if you go to a drawing and annotation workspace, this will emphasize all the tools required for 2D. So there are many different workspaces that are offered by AutoCAD. This is drawings and annotations, there's 3D basics and 3D modeling, which once again is the same as 3D basics, but a little more advanced features also available over here. And then you also have the AutoCAD classic version, which is the older version of AutoCAD. So we can also create our own customized workspace by modifying the interface layout, adding or removing more tools and so on. You can also make changes and then save your current workspace as a separate workspace as well. But by utilizing workspaces, we, the users, can optimize our productivity, reduce more clutter, and access the necessary tools more efficiently, thus resulting in a much more smoother and more focused drafting or modeling experience. Let's switch this back to drafting and annotations and talk about the next thing, which is the standard settings in AutoCAD. Alright, so talking about the standard settings in AutoCAD, we can first start with units. Now, what are units? Units are basically a way for you to represent the measurement and precision that you use for drawing and editing objects. So AutoCAD supports various unit types such as feet, inches, millimeters, centimeters, and many more. To set the appropriate units, you can very simply just write UN, enter, and that will basically bring up the drawing units for you. And there you can choose the type of units you want for your length as well as your angle. Inside the type for length, you have architectural, decimal, engineering, fractional, and scientific. If you hover your mouse over here, it will let you know that the values include the following, and the engineering and architectural formats produce feet and inch displays, and assume that each drawing unit represents 1 inch. So you can choose what kind of type would you like to use for your angles as well, and also set the precision. Precision basically means how many places do you want after the decimal point. So you can change the level of precision as per your needs, and the same thing happens for your angles as well. At the same time, you can also state how you'd like the angles to be measured. Over here, by default, it's anti-clockwise. That means the default direction is counterclockwise, which is for positive angles. But if you want the positive angles in the clockwise direction, you can just click on this. That's it. At the same time, we're talking about the insertion scale. That means a unit to scale in the inserted content. How would you like the units to be stated in a unitless system, inches system, feet, US survey feet, miles, millimeters, centimeters, and many more, going all the way up to light years and even parsecs. So this is basically how your sample output will look like when you set your units. Once you are done setting the units, you can just click OK and the units will be set. Then we also have something else called the limits of a drawing. So basically, let me just delete all of these and show you what limits are. In order to set limits for your drawing, I'll first kind of create a simple rectangle to show you an idea of what limits are like. Okay, so this is just the regular rectangle. This rectangle has nothing to do with the limits, but I'm drawing this rectangle to show you how limits really work. So in order to set limits for a drawing, you can just write LIM and you'll get this option showing up like limits. Hit enter and it asks you to specify the lower left corner. So you can click anywhere in this workspace. The workspace is this entire black sheet. I'm going to click on this bottom left corner of this rectangle. And now it asks me for the upper right corner. I'm going to click the upper right corner. Now, when I draw a simple line by hitting L enter, you'll see that nothing really happens. I'll explain why. Okay. So firstly, what are limits? Limits basically make sure that they define the drawing boundaries or the extent of a drawing area. Basically, they establish the maximum X coordinate and the maximum Y coordinate that AutoCAD should consider when displaying and plotting an object. So by setting these appropriate limits, you can ensure that the drawing remains within this area and prevents you from drawing an object beyond the desired boundaries. But how do you set these limits? Because when I hit L enter, I could make a line beyond the boundary. So how do I prevent that from happening? In order to prevent myself from drawing an object beyond this boundary, I'll once again write LIM to get my limits. And once I write LIM for limits and enter, you'll see that it asks me to specify lower left corner or on and off. Do you want to turn on or off your limits? The limits by default are off. I'm going to turn them on by just clicking on over here. All right. Now that the limits are on, once I hit L enter again, I click and I try to click outside. It's not letting me draw the line outside. No matter how much I try, I can't click out here. The only time it allows me to place the line is when I draw it within this boundary itself. That's it. That's exactly how this works. Anytime you try to click anywhere outside this boundary, it will not allow you to place that line. Only within the boundaries of this box are you allowed to draw your objects henceforth. Okay, so that's basically the limits, and these are how you set your drawing settings. All right, these are the standard settings and how you set them. Also, sometimes what happens is you might have your own kind of custom settings for your limits, for your scales, for your units, and so on. So how do you set these up in a manner that you can use them in every drawing henceforth? Once you have a particular setting, you can just very simply click on the top left corner and save as a drawing template. So in this drawing template, it's going to save this file in a manner that it can be used to create a new drawing the next time. So once you click on this, a folder will open up where you can see all the different drawing templates that are available. Here you can have your own custom template called personal template. All right, I'm going to call it the personal template and I'll hit save. That's it. I can give a description for what this template is. I can basically state what kind of units I'm using, what kind of standards I'm using, anything that I need to define this template, and click OK. All right. Now, anytime I want to start a new drawing, I'm going to go back to the Start tab. I don't really have to directly click New. I can choose my template. So I can just click on this drop down option here, click on Browse Template, and then choose my personal template, so that every time a drawing starts, it's going to be set at whatever units and boundaries I have set it up at. If you guys remember, then in the rectangles drawing, I basically made sure that I set this at clockwise, and that same setting has been imported over here. And that's basically how you work around with the drawing settings in AutoCAD. Lastly, we'll have a look at the function keys in AutoCAD. So let's take a new drawing, which is based on our personal template. And over here, let me just draw a simple line and let me explain all the different keys that are present over here. So I'll enter and the limits are set. That's why I'm not able to draw outside the boundary. So let me just turn off the limits. And let me just draw a simple line for you first. Okay, so let's talk about all the different function keys that are available in AutoCAD. F1 is basically for help, which lets you get the Autodesk help menu, all the different kinds of articles in regards to AutoCAD. And if you have any kind of questions or if you're confused with any kind of menu, you can just kind of write that thing here and you'll get different articles on it. Like for example, let's say I'm confused about lines. I'll just write line, hit enter, and I'll get quite a few different articles on lines and different options with there. If I want to read something about the line command, click on that and AutoCAD's official documentation on the line command will be provided to you on what are the different things you can do, how you specify the first point, and so on. So that's F1. And at the same time, whenever I click on any of the function options, you'll see that the option shows up at the bottom here. F2 basically opens up this thing, which is your command panel. So this whole thing opens up to display the different dialogues that you've performed in the history of your file. So you can see that the first thing we did was hit cancel. That's because I keep hitting the escape key. I hit L to get the line command. I have specified first point and so on. So that's F2 to enable and disable the command dialog box or see the history over there. F3 is for OSnap. OSnap basically means object snap. So like for example, if you're drawing anything, like I'm going to write L, enter, and I'm going to click anywhere randomly. And now when you click on F3, you can actually change your options while you're in the middle of a drawing as well. So you can see that it now shows OSnap on. I'm going to turn it off now. It's off. Now this line over here is an object. If I take this cursor of mine and I try to hover it on this line, you can see that it nowhere kind of shows up that there's a point on the line. I assume that this line is meeting here, so I click over there. Okay, now let's zoom in. If you zoom in, you'll see that, okay, you're not connected to that line. Hit L, enter once again, and now I think, okay, maybe this point is in contact. I zoom in again, and once again it isn't. So how do you prevent that from happening? How do you make sure that if you are creating a line, it actually selects this point? That's where object snap comes into play. F3, object snap on, and now it actually gives you a green square to indicate that that's the endpoint of your line. So click on that and now those lines are connected. That's basically F3 or object snap. We won't be working with F4, F5 and F6 as of now. F4 is basically 3D object snap, which basically suggests that when you're working with 3D objects, that time you can snap on a 3D object and all. F5 is for isometric drawings. When we get into isometric drawings, you'll see how F5 helps us. F6 also is dynamic UCS, which is something we're not getting into, but we need to work with F7. F7 is grid. As you can see that these boxes are showing up in our drawings, that's basically the grid. If you want to turn off the grid, you can hit F7 and once again hit F7 to turn on the grid. Please know that all the options that we're using the function key is available at the bottom over here as well. You'll notice these options switching on and off, like F7 is this particular option here. So you'll notice that when I hit F7, turns on and turns off as well. All right, so that's grid on and off through F7. Next one is F8. F8 basically means ortho on. When I make a line, L, enter, I click anywhere. Now you'll see that I'm only able to draw this line in the 0 degree angle, 90, 180, and the 270 degree angle. That's it. I'm only able to draw this line in these degrees. That's because the ortho mode is on. If I turn off ortho, I can now freely just draw the line at any angle and at any point that I want. If I ever want to make a horizontal line or a vertical line, that's where F8 helps me out. So F8, horizontal line and vertical line. That's F8. All right. Then comes F9. F9 shows snap on. Now this doesn't really look like there's any difference, but when you zoom in, you'll notice that it only lets you snap on the points of the grid. That means it only lets you draw a line on these points on the grid. If you ever want to escape from that, hit F9 once again and snap off. So now you can draw freely without being restricted by these grid points. Once again, F9 to snap on and F9 to snap off. All right, that's snap on and off, F9. F10. F10 basically means polar on. Now, polar is basically your angles. Now, when I turned on F10, you can see that it now gives me the 0 degree angle, the 330 degree angle, and it's showing me 330 because I have selected it to be in the clockwise direction. I can just change that to anti-clockwise by turning off clockwise from units, hitting OK, L enter once again, and F10 to turn on and off polar. Turning it on, I get the 0 degree angle, I get 30, 60, 90, and so on. You can see that I'm getting angles in the 30 degree interval. If I ever want to change these angles, I can very simply just go down over here. And here you can see that it shows you polar tracking, which is your F10. So in there, you can just click on this option here and change the interval degree. All right. If you want it to be in the 45 degree interval, you can click on this. And now when you hit L enter, you will see that the line is available at 0, 45, 90, 135, 180, and so on. All right. You can also provide your own custom polar angles by once again clicking there, clicking on tracking settings and clicking additional angles and then giving a new angle in there. So I'll click on new and put any number down in there. Let's say 37 and hit enter. That's it. Hit OK, come back down over here and you'll see that 37 is now available. Click on that, L enter, and now you can see that you'll get lines at every 37 degrees interval. All right, 37, now we have 74, then you have 111, 148, 185, and so on. To delete that angle, once again, go back down, click on tracking settings, choose the angle, delete, or just turn off additional angles. But if you want to delete it, select it, hit delete and hit OK. Once you come back down here, you'll see that the 37 degree angle is no longer present in there. That was basically F10, which is polar on and off. If you ever want to draw any line or any object with some degrees and you need help in the degrees that you're working with, just turn on F10 and you'll get the angles that you want to work with. All right. And then comes F11, which means object snap tracking on. Now, when we say object snap tracking on, we've seen what object snap is, right? When I make a line, if I draw the line and I want it on some point on the object, I can just hover over the object and this green option will be shown up on it, right? You'll see these green icons showing up on it, which represent the end point. You'll see the center point with the triangle and so on. Now, object snap tracking is basically when you want to snap on an object, but also track that particular point. So let me hit L enter, choose a point. And now if I hover my mouse over, let's say this point, there it actually creates this green plus sign that you can see. That plus sign is basically a snap tracker, which basically lets you track across that point. So once I hover on top of that object, you'll see that I'm able to track that point and draw a line across that. So that's what object snap tracking is. You want to basically snap on an object and then track that line. All right. If you ever want to turn off this green line, which helps you track across the object snap, just press F11 and you'll no longer be able to track across it. All right. You will no longer will be able to track across it. The reason you're seeing these is because F10 is on. That's for your polar angles as well, right? It will, however, give you representations for the perpendicular angles to that, but you won't get any object snaps in the other angles that you would wish for. All right. You can't track them in the other angles. So hit F11 and now you'll be able to snap and track across the object. Please remember that by default, even if you turn the F11 object snap tracking off, it will make sure that it gives you the perpendicular angles to that particular point. Okay. And F12, which is basically to turn on and off the options that are showing up besides the crosshair. You can see that it shows over here, specify next point, or in blue, it's highlighting the points. If you want this to go away, because sometimes it gets a little disturbing to, draw with all of these. So if you want a clean interface, just hit F12 and now no longer will the commands show up besides your crosshair. They'll show up just at the bottom over here. Hit F12 once again and the options will once again show up. All right. So these are the function keys in AutoCAD. Please make sure that you get very comfortable with the function keys in order to understand how you can actually work with AutoCAD more efficiently. All right. So with that, I'll see you in the next session. Until then, stay safe. Take care. Bye-bye. Welcome back. So in this session, we explore all of the different drawing tools in AutoCAD. So let's get started. First, we'll take a new sheet, and in this new sheet, first thing I want to do is turn off my limits, because if I draw any kind of line, you'll see that it'll let me know that I'm outside my limits. So let's first turn off our limits by hitting LIM, enter, and click on off. All right. Now that we don't have any limits restricting us, let's get started with lines. In order to use any command, just type the letter directly. You don't really have to click anywhere in the command or anything like that. Just type the letter L while you are in the workspace. When I hit L, this drop down option comes in. I hit enter, and that's the command for line. It asks me to specify my first point. I click anywhere I want, and then I can give a distance for my point. Like for example, let's zoom in a little bit, and I can give a certain distance that I want. Let's say, for example, at a 0-degree angle. So I'll turn on ortho mode, hitting F8. At a 0-degree angle, I want the distance to be 100. 100 is what I type. I hit enter. That's it. A line has been created of the length of 100. I keep my cursor upwards and again type 100. I have the second line, keeping it towards the left, 100, and keeping it towards the bottom, or just clicking on this point. Once I'm done, you'll see that the line command still continues. If I turn off ortho, you'll see that the line command still continues. To exit from the line command, you either hit enter or escape. So I'll hit escape, and that's it. It cancels the command or ends the command over there. That's line. All right. In line, once again, when you hit L enter, if you turn on your polar, which is F10, after you click your first point, you can turn on F10 to have your line at a certain angle. In order to give any particular length, just hold the cursor at that particular line and then give your dimension like 150, and that's it. A line at the angle of 27 degrees apparently in our case has been specified because our polar angle apparently was set at that degree. So we got to change the tracking settings if we need to. So we can also change the increment angles over here. Let's change the increment angles to 5. All right. So when I change the increment angles to 5, you'll see that in here, you see that all these degrees are showing up like this. Now this is showing up as 270, 315 and so on because of our settings. If you hit U and enter, we've selected it to be clockwise. That's why it shows it to be like that. So just uncheck it, hit OK, and now we can kind of easily work around with our angles. So if I keep it on a 30-degree angle, hit L enter, select a point, and now at every 30-degree angle, I can keep drawing my lines. That's lines for you. Okay. Another thing over here is how do you select items? When you select items, if you just click and leave the mouse, when you drag to the left, you see a green box. To the right, you see a blue box. Whenever you have the green color box, any object that's in contact with the green box will be selected. Like these two lines are in contact with the green box. Both the lines get selected. But if you click and you drag, you have to leave the mouse button and drag, okay? Because if you hold the mouse button and drag, it does something like this, okay? So if you click, leave your mouse button and drag, now comes the blue box. Any object that's completely within the blue box will be selected. Now see this. This line is in contact. That's not going to get selected. The line will get selected only if it's completely within the box. Okay, that's how you select it. And if you want to delete it, just click on the delete key. That's it. So similarly, select this and delete. All right. The next one is circle. In order to enable circle, you can either select the option from up here or just hit C and hit enter. Then it asks you to specify the center point for the circle. So click anywhere for now. That would be the center point, and it's asking you for the radius. I'd say that the radius is 50. And that's it. You now have a circle of radius 50 or diameter 100. But how do you give diameter for the circle? Once again, hit C, enter, select a center point, and now it says specify radius of circle or diameter. If you click over here, it's now going to ask you to specify diameter, or you can just hit D. As you can see, I have typed the letter D and I'll hit enter. It automatically switches to the diameter mode, and now you can actually specify the diameter of 100. And you'll see that both the circles look identical. In circle, you also have another option. When I hit C, enter, you see that there are 3 more options here: 3P, 2P, and TTR. Alright, and yes, if you want to move across the screen, press down the mouse wheel button and drag. Press down the mouse wheel button and drag. So, 3P. 3P stands for 3-point circle, where you choose the first point, the second point, and the third point. Let me just use some lines for reference. So I'll just create a sort of triangle here and hit C, enter, and just type 3P for 3-point circle, the first point, the second point, and the third point. It'll make a circle that passes across those 3 points. Similarly, in circle, you also have an option called 2P, which, as the name suggests, is just 2 points. So if you want to make a circle across 2 points, hit C, enter, type 2P, select the first point and then the second. Done. And the last one was TTR, which is tan radius. So if you want to make a circle across 2 tangents and then provide a radius, that's what tan radius does for you. So if I have this and this, all right. So C, enter, just type T for TTR or tan radius, and it asks you to specify the first tangent. This line will be the first tangent. Specify point on object for second tangent. So this is the line on which I want the second tangent, and now the radius of the circle. So if I put in, let's say 100, or maybe that's a little too large, I don't know. Yeah, let's keep it at 50 itself, because that way we'll get a circle which looks kind of like this. So let's put in 50 for our radius, and you'll see that the circle has actually been fit in here between those 2 lines, and it stays tangent to the 2 lines. But when you hit C, enter, one thing that you don't find is tan. That option is only present within the drop-down menu of circle. In the drop-down menu of circle, you'll see an option called tan present, which, as the name suggests, basically creates a circle across 3 tangents. So if you have a sort of triangle like this, and if you choose tan, you can choose each tangent line. So this is the first tangent, this is the second, and this is the third. And it makes a circle within that triangle. That's the different options in circle. Moving on, we now talk about arc, another important tool which is necessary when you're trying to create any of the engineering curves. So arc can be accessed using A, enter for arc. Arc by default, please remember, gets created in the counterclockwise direction. That means in this direction, like the way I'm moving my cursor. So only the first basic arc, which is the normal 3-point arc, works in this manner, where it asks you to specify the first point, click anywhere, second point here, and third point here. Once again. All right. Another option, if you want to repeat a command. Now, for example, I want to repeat the arc command. I don't have to type A again. I can just hit enter, and you'll see that my arc command gets restarted. Or let me hit escape to cancel the command. You can see I've cancelled it. I can hit space as well. Space and enter both can be used to repeat the previous command. So I hit space and now arc is repeated. So first point, second point, and third point. That's it. That's your first basic type of arc. Then within arc, you also have many other different types. If you understand the first three, you'll automatically understand the rest. The first three basically is start, end, center, start, center, end, start, center, angle, and start, center, and length. The rest are just different orders of the same three, meaning instead of beginning from start and then center and end, here it first starts, then makes you choose the end and then the angle. So they're just like shuffled ways of working with arc. But remember, when you're making an arc, make sure you make it in the counterclockwise direction. So start, center, and end. All right, let's say I have a line which is like this and like this. If I use the start, center, end, so this is the start point, this is the center point, and this is the end point. All right, whichever end point I want, I can specify over here. Okay, so I'll just specify it somewhere around here. That's the start, center, and end part. The next one is start, center, and angle. Once again, a start point, a center point, and then the angle from there. So what angle would you like to make the arc at? That's how you basically decide this. Okay. Now, let's say, for example, I wanted it at, let's say, a 45-degree angle. I'll just type 45 and hit enter. And this will actually make an arc of an angle of 45. Okay. So if I basically create a line like this and one more line like this, and if I try to take the dimensions, I know we've not yet discussed dimensions, but just to prove the point to you, right, you'll see that this is an arc of an angle of 45 degrees. Okay, that's the next one. The last one is start, center, and length. I say last because the rest are just shuffled versions of the same thing. So start, center, and length. So you give a start point, you give a center point, and then the length of the chord. That means this length. As you can see that there is an orange line being created. So that length or the chord length from one point to another. So if I, let's say, the chord length is 500, right? In this case, if I were to draw a line from this point until here, you'll see that it already shows up over here to be 500. But either way, I click on it and show you that the length in the linear direction for this particular line is 500. All right. So those are arcs. Moving on, we now have something called centerline. Now, what is centerline? Let's say I have two simple objects over here like this. If I wanted to draw a centerline between these two objects, I very simply can write CL and that will enable centerline. Select the first line and then the second line, and automatically a centerline gets created between those two objects. This is the centerline option. That's it. It very simply helps you create centerlines between two separate lines to represent any kind of, centrally passing object or anything like that. So once again, that's CL for centerline. Select the first line, the second line, and automatically a centerline will be created between those two lines. That's the centerline command. So we are yet to discuss rectangles, ellipse, splines, polygons, polylines, as well as points. So let's see that in the next session. Take care. Welcome back. So in this session, we continue our discussions on the remaining drawing tools. We start off by discussing rectangles, which very simply can be done by writing REC for rectangle, hit enter, and it asks you to specify the first corner point and then the next corner point. I'll just turn off polar so that this line doesn't interfere with my drawing. F10, and there we have it. All right. So now that basically is a simple way of drawing a rectangle. Once again, repeat the command, specify first corner point or some other options in here. So specify the first corner point, and once I choose the first corner point, it gives me a bunch of options: area, dimension, or rotation. First, let's go with dimensions. So let's hit D, enter for dimensions. It asks me to specify the length of the rectangle. I'll say that the length is 100. Okay, now it says specify the width. which is also 100 because I'm trying to make not a rectangle but a square. There's no separate option for a square. You got to use the rectangle itself when you're creating a square. So hit enter. And now notice that it's asking me to place the rectangle. I had selected this point to be the first point. The other corner point is your choice. It acts like the quadrants and lets you choose where you would like to place the rectangle across that point. Alright, so choose any point, click over there, and that's it. Your rectangle has been created. Once again, specify the first corner point or chamfer, elevation, fillet, thickness, and width. All of these options will be explored when we enter into the modify tools. So let's talk about those over there, as well as the rotation part. Even the rotation is another thing that you will find within the modify tools over here. So let's discuss that when we reach the modify tools topic. For now, we can talk about area. If you wish to give the area of the rectangle, you can select area and it asks you to enter the area of the rectangle. I'll say that the area of the rectangle is, let's say, 100,000, or let's make it 10,000. All right, not 100,000, that will make it too large. So hit enter, and now it asks you to specify, would you like to mention the length or the width? It's your choice. Like, one of the dimensions have to be provided, the other will be calculated. I would say I want to provide the length. What's the length of the rectangle? I'll say that the length of the rectangle is 500, and it automatically makes the rectangle for you, which gives you an area of 10,000. That's rectangles and how you draw squares in AutoCAD. Moving on, we now talk about ellipse. Ellipse can be found by writing EL for ellipse and enter. It asks you to specify one endpoint and then the other endpoint, which gives you the height of the ellipse, and then the width, which you can specify in half length. Meaning, for the height, you saw that we had to specify the topmost point and the bottommost point. That means you gave the entire height of the ellipse. Let's turn on ortho and keep the height to be 100. Now, in this manner, you're providing half the width. So you're going to say what the half width is. I'm going to say that the half width is 20. And so it makes one of the length of 40 like that. Okay. So repeating the ellipse command. So in there, you also have the option of arc and center. So let's see what those are. Let's go with center first. In this ellipse, we clicked the topmost point and the bottommost point. But when you click center, you can choose the center point of this ellipse. Let me turn on object snap tracking and let me track across this. So the object center point and then the length. So I'll give that to be 50 this time. Here I had entered 100, but here I'm entering 50, hitting enter. And now for width, I'm going to keep it the same as 20. And you'll see that this basically creates the exact same ellipse with the same dimensions. All right. Inside ellipse, you also have one more option, which is arc. You got to make sure that you click on the arc option first before you actually start drawing the ellipse. What this does is it lets you make an elliptical arc. So let's give one endpoint and the other to be 100 and then this width to be 20. Okay, now you'll see, let me turn off ortho, that you're able to click at a certain point. Remember that your arcs are always counterclockwise. So let's say I wanted an arc in this manner. So this will be the start point and this will be the end point. These are ellipse. All right. Moving on, we now have splines, which can be accessed using SPL. Splines basically let you draw contours like this. Once you're done drawing your spline, do not use escape because splines don't work the same way other commands do. You gotta either use space or enter. I hit space or enter and that's it. My spline gets created. If you click on the spline, you can control the spline using these points. You can also add an extra point by hovering over this point and selecting add fit point, which will let you add a point between these two points. And that's it. Then you can control the spline a little more. At the same time, you can click on this triangle looking thing to change it to control vertices, which lets you have a little more finer control on the curves on your spline. That's how you basically draw splines as well as control them. Moving on, You then have polygons given by POL for polygon. Hit enter, and the first thing it asks you is to enter the number of sides. I'd say that my polygon has 6 sides. So I'm basically making a hexagon. It asks me for the center of the polygon. Click anywhere, and then it gives you two options: inscribed in circle and circumscribed about circle. Let's understand what these are. Let me make a circle of radius 50, and I'm just going to copy the circle. Don't worry, we've not yet discussed copy, but we will understand it when we get there. All right. So over here, I've created two circles. Let's repeat the polygon command. Pass 6 as the number of sides. Okay. Specify the center and choose inscribed in circle. When I choose inscribed in circle, it lets me choose a corner point. Turning off ortho, it lets me choose a corner point. I'm going to just click on the point on the circle. And this is what I get. Let's repeat the command, repeat the sides to be 6 and specify center once again. But this time choose circumscribed. Notice that when I choose a point on the circle, this is what happens. In this case, the polygon is within the circle, or all the points of the polygon are inside or inscribed in the circle. Whereas in this case, each of the points are circumscribed about the circle, or basically they're outside the circle. That's what polygons are, and this is how you control them. The last one is basically points. You can enable points by writing PO for point, hit enter, and you can click, and that's it. A point has been made. Now you'd be like, I can't really see the point over there. Neither do I. Let me repeat the command. Okay, specify a point, click. Okay, apparently there's a point. Let's select it like this. And yeah, there are 2 points there, but they're not very visible, right? This is where you actually change the point style. In order to change the point style, you have 2 ways to do it. One is go into utilities, and in utilities you have point style, or just use the command p type. As you can see, when I hover my mouse over it, there's a shortcut shown at the bottom over there, p type. So you can just do that. So just write pt and p type should show up, hit enter, and then you have point style. When you choose a point style, like I choose this plus sign here, you'll see that the points show up or get represented with these plus signs. After this, whenever you repeat a point, you'll see that you can actually click anywhere and the points will actually be represented by this plus sign. Once again, pt for p type, and you can change all these points styles to, let's say, this one, and hit OK. And that's basically how you actually represent a point. If a point seems too large, you can once again repeat the point style command and change the point size. So if I say that I want it to be 3, in this case, it's 3%, or the size has been set relative to the screen. It's 3% of the screen size. That's what it does over there. At the same time, the other option was to set it in absolute units. So this is 3 units of a point. All right. So remember that when you are giving a point, you have these following options in there. The last command is a polyline. The polyline command, which is present over here, is given by PL, enter. Now, in the polyline, you can actually make zigzag lines like this and stop. The difference between a polyline and a normal line. Let's make a normal line as well. And you'd probably be telling me, yeah, what's the point of actually making a polyline when there's a normal line command? The difference is when you actually select a line, you'll see that the line is actually made out of individual lines like these. That means there's 1, 2, 3, 4, 5, 6. 6 individual lines are making up this zigzag line. But in polylines, when I click on even one of these, you'll see that the whole thing is being represented as one single object. See, when I click on this line, it's just one line. This is the second line. This is the third line. But in polylines, the whole thing is one single object. And polylines go one step beyond this to give you an option of also specifying arcs. That means while you're making these lines, if you want to switch to an arc, you can always hit A or click on this arc option here to switch to arc, and now you can just draw arcs in that polyline command. All right, that's basically polyline. And let's say, for example, you want to close this polyline, you can click over there or just directly hit C and it will close it on its own. So over here, basically it's asking you CE for center or for close. All right. So in that case, basically it didn't understand what I had to do there. But anyway, the point is when you hit PL enter, you create a bunch of lines like that. And if you want to close it, it's C to close, and then the lines will get joined. The whole thing will be represented as one object as opposed to line, which makes them as separate objects. All right. That's the difference between polyline and a normal line. This is one line, this is another, and so on. But this whole thing is one single object. These were basically your draw tools in AutoCAD. I'll see you in the next module where we talk about the construction tools in AutoCAD. Take care. Bye-bye. Welcome to module number 4 on construction tools. In AutoCAD, construction tools refer to a set of specialized commands and features that are designed to aid in the creation and manipulation of construction elements. These tools are particularly useful for generating accurate reference geometry in the construction of complex designs and ensuring precise measurements. Why do we even use them? Specifying the center line or center mark in engineering drawings serves several important purposes. Firstly, using these can help convey the precise location and orientation of features or objects in a drawing. They provide a clear reference point and aid in understanding the intended design and its alignment. Symmetry and balance. They assist in indicating the symmetry and balance of objects or features by helping us identify the midpoint or central axis, which is crucial for achieving a visually balanced and harmonious designs. At the same time, during dimensioning, center lines and marks play a significant role in them. They serve as a basis for locating and measuring other features or objects, ensuring accurate and consistent dimensioning across the entire drawing. At the same time, when it comes to alignment and positioning, they assist in maintaining proper spacing, alignments, and orientations that lead to a much more accurate designs in constructions. Then comes hole patterns and features. Center lines are particularly important in indicating the location and orientation of hole patterns such as bolts, circles, and so on. They help define the center point from which holes are evenly distributed, ensuring proper fit and alignment in the manufacturing and the assembly process. Now, speaking of manufacturing, they also act as a reference for manufacturing processes such as machining, drilling, or milling. They guide the setup and positioning of tools and equipments, which ensure precise manufacturing and facilitate inspection and quality control. Speaking of control, by specifying center lines, changes or modifications to a design can be easily identified and managed. These center lines act as a consistent reference point, aiding in tracking and communicating revisions throughout the design and manufacturing process. So in summary, by specifying our construction lines in engineering drawing, we enhance the clarity and we also enable communication and accuracy in our drawing. These provide vital information for dimensioning, alignment, symmetry, manufacturing, and revision control that contribute to the overall quality and efficiency of the design and production processes. Let's move on to AutoCAD to have a look at how we can actually create our construction lines. Alright, so we're here now in AutoCAD and we're going to get started with construction geometry. So let's take a new file. And in this new file, let's first check our limits. Let's hit L enter and check our limits. So we do have a limit restricting us. So let's disable limits by hitting LIM and now off. Alright, that should disable our limits, which should allow us to draw outside the boundary. Okay, now the first thing we want to discuss is ray. So a ray is basically used in engineering drawing to represent infinite lines that extend indefinitely in one direction. So when we use rays, we generally use them to indicate like the path of light, motion, or even reference lines for alignment and positioning of objects. So to access ray, you can type RAY for ray, or you get the option in the drop down menu of the draw panel over here, ray. Alright, so I'm just going to type RAY for ray and hit enter. Now when you click any point, you'll see that you're able to create, like I said, a single line that extends indefinitely in one direction only. So if I just click a bunch of these, you'll see that I'm able to create a ray like this. So all of these are just lines extending in one direction infinitely. That's ray. All right. Let me get rid of that. And let's talk about center lines. We've discussed center lines in the previous session, but let's talk about them once again. Center lines are used to denote central axes or midpoints of symmetrical objects or features in engineering drawing. Like for example, if I just draw this rectangle over here, it would look like a normal piece of block. It looks like a square box. But what if I told you that this was not a rectangle, but this is rather a cylinder viewed from the side, which means that the top view of this object is actually a circle. So how am I supposed to actually denote that there is a center line over here? Without the center line, I'm not able to actually specify what this object really is. So we've seen center line in the previous session, so we're going to use that once again. That's CL for center line, then select the first line and then select the second line. And you'll see that you kind of have this line over here, which is the center line being created. And also when you select this line, if you zoom to the top over here, you'll see there's a tiny little arrow, because this arrow is going to let you extend beyond the limits of the body. All right. So you can manually just select this and extend it like that. Or if that seems a little too tedious, you can always double click on the object and you'll get this centerline property box that opens up. And in here, you can talk about the start extension and the end extension. Maybe I want to extend the start by 150 and also the end by 150. So you'll see that the center line now extends beyond the boundary of the object. If you wish to change the line type, you can always choose the line and you'll see the properties of the line showing up over here. And in the drop down menu, you can change the option. Now, if you see that there's no option over here for any other center lines, you can always choose other and you can click on load. And in load, you'll see that there are three different types of centers here that you can see. Over here, this is a single dashed center, then a center 2 and a center 3 as well. So let's click all of them, hit OK. Since one of them has already been loaded up over here, which is center 2, we can kind of just reload the line type, it doesn't matter. And then click OK. Now when you select the line, you can actually just change it to whichever line type you would like. Like this looks much better to me, so I'll keep it as this. So this now helps me understand that this particular line or this particular object is a cylindrical object where this is the center line of that object. Now, I might sometimes want to make a top view of this object. So when I'm trying to make a top view of the object, it would always help if there was some kind of construction line that helps me out. In order to create a construction line, which is just a line that extends in both directions compared to the ray which extends in one direction, this is a line which extends in both directions. Very simply, you can just write XL for center line, hit enter, and then you got to just select a point. I'll select this point here and that's it. I can turn on ortho by hitting F8 and then create a center line going straight up. Similarly, I can also repeat the command and do the same thing over here. Now I kind of have what is an infinite line extending in both directions. This will act like a reference using which I can just make my circle, which would basically represent the top view of this object. So in order to make the circle, I can just select circle and choose tan radius, or I can just select a 2-point circle because that will just get my job done for me. So I'll just choose a 2-point circle, first point and second point. That's it. This is basically representing the top view of the object. For now, we'll just delete the center line as it is. You learn how to trim them later on and so on. Okay. Now, another important tool when it comes to construction geometry is center mark. Now, what are center marks? Center marks are used to indicate the center point of a circle or any symmetrical object like a hole or an arc in engineering drawings. So basically they provide a reference point for the positioning and dimensioning, particularly when you're actually drawing whole patterns, or you want to facilitate some accurate machining, drilling, or milling operation. That time center mark becomes really important. So when you're creating a center mark, you can do it manually by hitting L enter and just kind of drawing a line like that, repeating the command once again and drawing a line like that. But once you create the lines, they've got to be center lines. So you would select them and kind of change this to any of the center line setting that you would like. Now, the thing is, when you do draw a center mark, one of the rules is that you got to have a plus sign in the middle. So, when you kind of double click on this and you kind of try to change anything over here, you can't really do much, right? A lot of times you might kind of try to adjust things around and kind of bring this in the middle, but not a very efficient way of going about it. So AutoCAD has already given us a feature called center mark. So if you actually write center, you'll see over there that we have something called center mark over here. When you click on center mark, it's going to ask you to select a circle or arc in which you want to add the center mark. I click on this and done. There you have it. You have a center mark being created for this circle, and just like the center line, even the center mark will have the lines being extended beyond the boundary of the object, and you can double click on it just like you did for centerline and change the length of the extension. Let's make it 50, or rather let's change it a little bit more. Let's make it 100. All right, 100 over here, 100 over here, and 100 over here. That's it. If I hit no on show extensions, then you'll just see the cross mark in the middle. But when you actually allow extensions by hitting yes, you'll see that it displays the center line for the object. So this way you don't really have to draw the center lines. AutoCAD has already given you features that help you create them. And on this, you can absolutely create a construction line like that and like that, and change the line type for these into a center dashed line. This way you're representing the top view of the object and the side view of the object. And this is how you basically use construction geometry to state references in AutoCAD. Thank you.